AW and AE aspirants, welcome to Saimedha Koti Hyderabad, myself Surendra Babu. In this videos, I would like to discuss about detailed concept of Genco, Transco and Discom previous year questions. These are more useful who are preparing for AW and AE exams. This question is asked in EPDCL 2010 subject measurements topic CRO. Time-based generators are used in CRO produces dash waveforms. Students, we know that we are using time-based generator in the CRO to produce sweep signal or sawtooth waveform. Okay, very important statement that you have to remember, that is the time-based generators. Produces sawtooth waveform. Sawtooth waveform, or it is also called sweep generator, that is sweep signal. This signal is the base signal for all the input waveform. To drive the any waveform on the CRO screen, the base signal is the sweep signal, that is the sawtooth waveform. That is option 3 is the right answer. See the next question. This question is asked in EPDCL 2010 subject measurement topic CRO. CRO probe assembly is an application of multivibrator, attenuator, clipper, clamper. Answer is attenuator. Students, we know that in probes there is a attenuator probes are there. Attenuator probes. The attenuator probes are the N:1 probes. For N:1 probes, what is the probe resistance? The probe resistance equal to input resistance of CRO into N-1. This one important formula. What is the probe capacitance? Cp equal to input capacitance plus coaxial cable capacitance by N-1. That is Cp equal to Ci plus Cc by N-1. For this question, answer is option 2. Very important announcement from Saimedha Koti Hyderabad who are preparing for AW, AE, sub-engineer and JLM exams. We have the excellent online and offline platform for ECE, EEE and Civil. Students, there is one announcement from Saimedha Koti Hyderabad, Spacegate. We are starting a new batch on 8th August 2024. For more details, you have to contact the numbers. You have to utilize this opportunity, students who are preparing for AW and AE exams. This question is asked in Transco AE 2012 subject measurements topic CRO. The time per division and voltage per division axis of an oscilloscope have been arranged. A student connects a 1 kHz 5 volts peak to peak square wave calibration pulse to channel 1 of the oscilloscope and observes the screen to be as shown in the upper trace of the figure. Students, it is given that in upper trace of the figure there is a square wave. Okay, this is the square wave, students. This is in upper trace of the figure whose amplitude is the peak to peak voltage. That is the peak to peak voltage is given, it is a 5 volts. 5 volts peak to peak and frequency is 1 kHz. Frequency is 1 kHz. The upper trace of the figure. An unknown signal is connected to channel 2. Channel 1 is known signal, channel 2 is the unknown signal. As shown in the lower trace of the figure. Okay, this is the unknown signal displayed on the CRO screen. If the time per division and volts per division for both the channels is same, the amplitude, that is peak to peak voltage and time period of the unknown signal is, you have to calculate the time period and peak to peak voltage of this signal, students. If you have to find what is the peak to peak voltage and time period of this signal, first you have to know what is the volts per division and time per division of this waveform. But one condition is given in the question, if the time per division and volts per division are same, then for a known waveform you have to calculate the volts per division and time per division, use the data to calculate peak to peak voltage and time period of the unknown waveform. Students, we know that what is the peak to peak voltage? The peak to peak voltage formula in CRO is NV into Y. How much peak to peak voltage is given? 5 volts. NV is the number of vertical divisions occupied by the displayed waveform. This is the known waveform now. How many vertical divisions it is occupied? 2 divisions. 2 vertical divisions it is occupied. That is 2 into Y. Then what is the vertical setting? 5 by 2, that is 2.5 volts per division. 2.5 volts per division. This is called Y setting or vertical setting. Then what is the formula for time period, students? Generally time period is calculated for 1 cycle. Then 1 cycle time period equal T1C equal NH into X. But instead of time period, here it is given frequency. I am writing 1 by F equal to NH into X. Then from this you have to calculate the what is the X setting. That is the X you have to calculate. X setting, horizontal setting or sweep setting. These are the different names. Then NH into X equal to 1 by how much frequency it is given? 1 kilohertz. 1 into 10 cube, that you have to write, that is 10 power minus 3. Then from this what is X equals, friends? That is 10 power minus 3 by NH. How many number of horizontal divisions occupied by the displayed waveform? These are the horizontal divisions. This is for 1 cycle. You have to take for 1 cycle. For 1 cycle 1, 2, 3, 4. This total it is occupying 4. That is 10 power minus 3 by 4. This is equal to 0.25 milliseconds. Then what is the observation here, friends? For this known waveform, Y setting is 2.5 volts per division. X setting is 0.25 milliseconds per division. That is 0.25. It is equal to 0.25 milliseconds per division. This is X setting, 0.25 milliseconds per division. With this data, we have to calculate the what is the peak to peak voltage of unknown signal. What is the peak to peak voltage of unknown signals, friends? The peak to peak voltage of unknown signal, if you have to calculate, then you calculate the vertical number of divisions. The formula is NV into Y only. How many number of vertical divisions occupied by the unknown waveform? This 1, 2, 3. This is 3 into, what is the Y setting? 2.5. This is equal to 7.5 volts. What is the time period of unknown signal? NH into X. NH into X. How many number of horizontal divisions occupied by this waveform? 1, 2, 3, 4, 5, 6, 7, 8. That is 8 into, what is the X setting? 0.25. This is T1C equal to how much we can get, friends? That is 2 milliseconds. That is for unknown waveform, whatever the waveform displayed on the screen, whose amplitude is peak to peak voltage, not amplitude, it is a peak to peak voltage 7.5 volts and time period is 2 milliseconds. 7.5 volts 2 milliseconds. For this question, option 3 is the right answer. Very important announcement from Saimedha, Koti, Hyderabad, who are preparing for AWE, AE, sub-engineer and JLM exams. We have the excellent online and offline platform for ECE, EEE and Civil. Students, there is one announcement from Saimedha, Koti, Hyderabad, Spacegate. We are starting a new batch on 8th August 2024. For more details, you have to contact the numbers. You have to utilize this opportunity, students.